Today what we're going to do is we're going to look at section 10.4. We're going to use inscribed angles and polygons. So 10.4 is using those angles and polygons, and the main thing that students really get confused on is what is the difference between a central angle and an inscribed angle, and they are definitely different. The first thing that we're going to look at is we're going to look at something called a central angle. And what it makes a central angle is you'll notice that the vertex is at the center of the circle. And so the angle starts on the edge of the circle. It goes to the center of the circle, the vertex. And then it comes out and it hits another part of the circle. Again, the main idea is that the center of the circle is the vertex of the angle. So again, this is called a central angle. Right there. Now, an inscribed angle is different. It's when their vertices are on the circle. They're not in the circle. So if I take a look at this, an example would be, A vertex is on the circle, on it, not in it, and then it goes to B. And there are several inscribed angles here. If you're confused about the picture, let me draw another picture off to the side to kind of help you with that. So if I have a circle, and here's the center of the circle. The inscribed angle starts on the circle. It goes out to a point on the circle, and then it comes out to the circle again. So the starting point is here, the ending point is here, and the vertex is on the circle. It's not the center of the circle, so you can kind of see the difference. Okay, so if I take a look at this picture one more time, an inscribed angle is A, and then it goes to B. Another one would be I start at A and I go to, I go here and I go to B. There's another inscribed angle. Another inscribed angle is A, and it goes to there and then there. Another goes from here to here. And finally starts at A, goes to B. So you're going to notice that the vertex of the angles at different spots, but A and B are always constant. So all of these angles that I just outlined are inscribed angles, and their arc is AB, because again, they started on A and they ended with B. And so they have the same arc AB. All right, let's take a look at this. Again, same picture. All of the inscribed angles here, they are congruent. Even though they don't look congruent, they are congruent because they have the same arc. Okay, so let's take a look at this example. It says that the measure of angle D, so here's the measure of angle D, here's D. Okay, that's an inscribed angle. Okay. How is that in comparison to angle B? Angle B is a central angle, okay? So the measure of angle B is 102 degrees. And if you look at the measure of angle D, you're going to notice it looks smaller, okay? And in fact, it's half of B. So the measure of angle D is going to be 1/2 of 102, which is going to be 51 degrees. So it is half of the measure of B. If I take a look at angle E, okay, so I'm going to highlight angle E. Here's angle E. Okay, now you're going to notice that that is also an inscribed angle, and it's asking you about arc AC. So here's AC. Okay, so again, arc AC is the same thing as the central angle, because remember the arc measure and the central angle would have the same measure. So if you take a look at The measure of angle B, we said that it was 102. That is the same thing as the measure of arc AC. So if I'm looking at the measure of angle E, the measure of angle E is going to be smaller than the arc. So it's going to be 1/2 of 102, which is 51 degrees. So the arc is going to be half of that angle. Okay. Again, the central angle is always going to be larger than the inscribed angle. Let's start looking at this a little bit closer. An angle inscribed in a semicircle is a right angle. So let's talk a little bit about that. If you take a look at a semicircle, we said that that was always 180 degrees. And an inscribed angle, we said, was half of that. So that would make sense that this inscribed angle then would be 90 degrees because it's half of 180. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So that's another thing we're going to look at. If I take a look at this quadrilateral, you're going to notice that it's inside the circle. And it says the opposite angles of it are supplementary. So what that means is it means that if I take the measure of angle R right here, and I add the measure of angle T, because they're opposite, that's going to give me 180 degrees. Notice that the quadrilateral is inscribed, which means its vertices touch it, and it's inside the circle. And then I would also say the measure of angle S plus the measure of angle U is also 180 degrees. And that's going to be really important when we solve some equations. Let's keep going. On this example, we are going to find X, and you're going to notice that the quadrilateral's inside, it's inscribed. And so what I'm going to do is I'm going to take this angle right here and this angle right here, and they are supplementary. So I'm going to say 4x plus 4x plus 20 equals 180. 8x plus 20 equals 180. So I'm bringing together like terms. I'm going to subtract my 20s. So 8x gives me 160. And then I divide by 8. So x equals 20. And it's 20 degrees. Okay, if I wanted to find y, you're going to notice that was x. If I wanted to find y, what I would do is I would take, again, those. They are opposites of each other. And I'd add them together and make it 180 degrees. So I come over here and I go, okay, I'm going to take y plus 50 equals 180. 2y plus 50 equals 180. Again, I'm going to combine like terms. 2y equals 130. And if I divide by 2, y gives me 65 degrees. So again, I do that because the quadrilateral is inscribed or inside the circle and its vertices are on the circle. Okay, now let's keep going and let's take a look at this example. Now again, you're going to notice that angle ABC is an inscribed angle. Okay, again, remember that if it's inscribed, okay, it's going to be half of the central angle. And it's asking me to find the measure of arc AB. So it's asking me to find this. Okay, so a couple of things. First of all, I know that if this is 38 degrees, then I know that I need to find out this arc measure right here, AC. So what I'm going to do is I'm going to go the measure of arc AC is 2 times 38. Because again, the inscribed angle is half of it. So this is going to end up giving me 76 degrees. So this arc right here is 76 degrees. Another thing that I know, if you take a look at the picture really closely, and I'm going to erase some of this right here. If you take a really close look, arc BC is a semicircle. And the reason why it's a semicircle is because this is the diameter. So I'm going to name this arc, AB, I'm going to call it Y. And I know that if I take Y and I add 76, it's going to give me 180 degrees. So Y, which is the measure of arc, AB, is going to give me 104 degrees. Now, you didn't have to name that arc Y if you didn't want to. It was just another way of looking at it. But you take 180 degrees and you subtract your 76 and you end up with 104 degrees. And that's it for today. If you have any questions, please feel free to let me know.